All right, mathletes, we're going to continue on with what we learned yesterday, or in that first video for 5.5, the remainder and factor theorems, which dealt with synthetic division and long division, so we can divide one polynomial by another. Remember, you can only do synthetic division if you are dividing by a linear binomial, which is what we have in this first example here, a linear binomial with a coefficient of 1, which is what we have here. So I've already set this up, where we have our coefficients of the dividend. Okay, this is what we're dividing by this. So f of x is considered the dividend. I put those coefficients there. We're going to divide by x plus 5. Well, when you're dividing by x plus 5, the possible 0, if it is 1, is negative 5. So that's what we want to put in this box right here. Okay. Oh, actually, I've set this one up a little bit differently because I don't know who you'll have in future math classes, how they'll do synthetic division. I usually put a box here and a line, but what I see often from other teachers is this setup here with this box like this. It doesn't matter. I just thought I'd show you this other way to do it. It's the same process. Okay. So we're going to drop the 1. Probably fill this in here. This is the possible 0 of the function f of x. It will be a 0 if we get a 0 at the end. We don't know. So we drop the 1 and we multiply by negative 5. We add these together. Then I multiply. We add these together. Then I multiply. Negative 5 times 12 is negative 60. I add these together. Hey, that's special because that means that negative 5 is a 0. We knew it was a 0 of this one. When I say possible 0, I'm not saying it's possible 0 of this guy. We know it's a 0 of that thing. We're wondering, is negative 5 a 0 of this guy? Or is x plus 5 a factor of this guy? All right, well, we just found out it is because we got a 0 at the end. Okay, so a couple of things here. That first line, 1, 12, 47, 60, are the coefficients of f of x, which is the dividend. I was kind of saying all this stuff. I should have been filling it in as I said it. What we get here are the coefficients of q of x, the quotient. And then the remainder at the end. Well, there is no remainder because we got a 0. Okay, then remember that this represents the coefficients of our quotients. Okay, our quotient is x squared, because remember, this was x cubed, and we drop a degree when we go down there, so that 1 below the line represents x squared. This is plus 7x then, and then this is plus 12. There is no remainder. So here's where this thing, being a 0, becomes really important. Because that's a 0, because the remainder is 0, and because f of negative 5 equals 0, I don't know why I have these parentheses here. This should just be f of negative 5, because that's essentially what we put in for x, was negative 5. Since that's 0, we know all the following things. We know that negative 5 is a 0 of f of x. We know that x equals negative 5 is a solution or a root of f of x equals 0, if we set f of x equal to 0. Okay, that's really what that should say right there, of setting f of x equal to 0. If we set that function equal to 0 and solved it, one of our solutions would be negative 5. We also know that negative 5 comma 0 is an x-intercept on the graph. Now notice the difference in these things, because right now a lot of us are, when I ask you for zeros, you're giving me this. It's kind of true, but they're two different things. The 0 is negative 5. The x-intercept is negative 5 comma 0, the point on the graph. Now, here's where things switch a little bit. Because we got a remainder of 0, we know that that guy is a function. So, a factor, sorry. So we know that x plus 5 is a factor of f of x. Okay, but here's the key thing. We know that that's a factor too. X squared plus 7x plus 12 is also a factor. Okay? So as a follow-up question, let's put this right here. As a follow-up, What if you were asked to find all the zeros of f of x? Okay, so we're dealing with the same function. Okay, well, we already found one. One is negative 5. We could find the others by solving x squared plus 7x plus 12 equals 0. Well, that guy happens to be factorable too. X plus 4 and x plus 3. So that means that our zeros from those are negative 4 and negative 3. So all of our zeros of f of x would be negative 5, negative 4, and positive 3. So as a little added bonus here, what if we graph this thing? We got negative 5, negative 4, and 3. It doesn't have to be to scale. What was the other thing that we knew about this? Oh, the y-intercept. The y-intercept of the original function is 60. All right, we're not going to get, I don't care how not to scale this is, that's pretty high. I just recognized something here. I'm sure you all recognize this already. That should be negative 3, right? X plus 3 becomes negative 3. That should be a negative 3. That's in the wrong spot. You know how I knew that? Because of end behavior. Of course, I can't just erase that. I got to get rid of the whole thing. Because I was looking at the end behavior, and I was looking at, there's our negative 3, end behavior, and the y-intercept weren't going to match up. Okay, I'm going to start this all over again. Zoom in a little bit. So we've got negative 5, negative 4, and negative 3. There we go. Now, this is an odd positive function. So we know the end behavior should look like this. Okay, and it could be doing whatever on the inside. All right, so we know it's going to go like this. Through there, and through there, and then it's going to end up crossing at 60 on the y-axis. But the end behavior, the zeros, the y-intercept, all that stuff should match up when you think of what the graph looks like. All right, so it says these incredible discoveries that we've made actually make up two very important theorems. And we've kind of talked a little bit about them already. The remainder theorem, the factor theorem. If a polynomial is divided by x minus k, then the remainder is what you get when you put k into the function. And the factor theorem says that a polynomial has a factor of x minus k if, when you put it in, the remainder is 0. Okay, and we've kind of said those things already. Here they are written for us, the way that you would see it in your textbook. All right, so in a general sense here, got a bunch of numbers up here that are the coefficients of f of x. We're going to divide by x minus k. So that means that we'd put a k right there, okay, or whatever value it is. When you go through your division, r is your remainder. Okay, that's the remainder theorem, that when you put k in, r is what you get back. The remainder is that value you get when you put k into the function. Okay, and if we continue on with everything that we wrote above, if we know this is what happens, then, and if we know that, and this is important, if r is 0, it's pretty important. If r is 0, or if when you put f of k in and get 0, this should be f of k. Man, I got a lot of mistakes on here I got to fix. F of k is 0, then we know the following. K is a 0, x equals k is a solution, k comma 0 is an intercept, is a factor, and then the quotient is also a factor. Okay, but that's only true if you get a 0 at the end. All right, let's use that to our advantage here. So these are the different scenarios that you could be asked in the problems in your homework, in a quiz or a test, or life in general, right? So you could be given one factor of a polynomial and then asked to find the other factors. You could be given 1 0 of the polynomial or one solution, kind of the same thing, and then you could be asked to find all the other zeros or solutions. Or you could have a kind of a combination of the two things. And we've got examples below that are going to follow all these ideas. So the first one says, factor the polynomial completely given one factor. Write the function in factored form. Okay, so here's the original function, f of x. This is the one given factor right there. So we're told x minus 4 is a factor. We're being told that, okay? So we know now, this is a little bit different than what we've done in the past. We know when we put 4 in, we know we have to get 0 right there because they told us it's a factor. So if we don't get 0, something's wrong. Let's go ahead and do the synthetic division here. And synthetic is okay because it's a linear binomial. So we've got 1, -6, 5, and 12. And I put, now notice how this is x minus 4, but I put the possible 0, which is positive 4, into the box. So we drop the 1, multiply, add, multiply, add, multiply, and just like we expected, we got a 0 there. Okay, and we expected that because we're told it's a factor. So this is x squared minus 2x minus 3. You need to factor that further if you can. Okay, are there two factors of -3 that add to -2? We got x and x, minus 3 and positive 1 is what that would factor to. So that factors further, we have all three factors. We know that this function can be rewritten as, don't forget the 4, actually I should say the x minus 4 is one of the factors too, because we got a 0. So we have x minus 4, x minus 3, and x plus 1. Now what happens if this is factorable? That's okay. You just put that down as one of the factors then. But in this case it was factorable. Okay, let's try the next one here. We've got x minus 2, so I want to put a 2 in the box. 1, -1, -22, and 40. All right, now we're expecting to get a 0 at the end, so we drop the 1, we multiply, we add, we multiply, we add, we multiply. Oh, it's all turning up golden for us today. We got a 0 there, good. All right, so we have x squared plus x minus 20 is what that represents. Because remember, this was x cubed, and we drop a degree when we drop below the line. This can factor to, let's see, we'll start with that. We need factors of 20. Difference of 1, 5, and 4, right? Okay, it's got to be a positive 1 difference. So this has to be positive, that's got to be negative. So our factorization becomes x plus 5, x minus 4, doesn't matter what order you put these in, and then don't forget to bring that x minus 2 down as well. So that's one scenario. Another thing you could be asked is to find zeros given 1, 0. Okay, so here we're told that x equals 4 is a 0. 4 is a 0, x equals 4 is a solution, okay? So we're going to put 4 in, not -4. They don't give us a factor there, they actually give us the 0, so you put the 4 in. 1, -2, -23, and 60. Hopefully you're starting to see why we did synthetic substitution a week and a half ago, whatever it was, and everybody complained at first because you just wanted to plug it in instead. This is why. All right, this is so much easier. So we drop the 1, multiply, we add, we multiply, we add, we multiply, and again we get a 0, just like we thought we should. Is this factorable? Let's see. This was an x cubed, so this is x squared. X. Now let's see, we've got a positive 5 and a -3. Now, they're not asking us to factor it. They're asking us to find the other zeros. So the other zeros would be -5. So the other zeros are -5, -5 or 3, -5 and 3. Either way is acceptable. All right. Now this time they tell us, look at a graph. Okay? Because what you're going to have to do at some point is you're just going to be given this and nothing else. They're just going to say, find all the zeros. And it's not factorable. Okay? Actually, this one is factorable. If you look at it, it's groupable. But I'm sure you noticed that. but sometimes it won't be factorable. So what you're going to have to do is graph it on your graphing calculator. And on your graphing calculator, you'll be able to identify a 0. In this case, that 0 is 1/2. So that's the 0 that we want to put in here. Okay? 2, -1, 2, -1. Drop it. Multiply. Add them. Multiply. Add them together. Multiply. We get a 0. Okay, so now you got to be careful here. This was 2x cubed. This is 2x squared. 0x plus 2. I don't need the 0x. There's that. I want to find the other 0. So I take what I'm left over with here and I set it equal to 0. Okay, a couple different ways you could do this. You could factor out a 2. I'm just going to subtract the 2. Because I have no b term, I'm just going to subtract the 2 and divide by 2. Okay, it's okay to divide by 2, you just can't divide by a variable. You always have to pull variables out as GCFs. But in this case, I get x squared equals -1. If we take the square root of both sides, we get x equals positive negative. Don't forget the square root of -1 has a special value. The square root of -1 is I. So we have 2 imaginary zeros there, which makes sense because look at this thing looks like it's an odd, and it's only crossing one spot right there. There's no way it could come back and cross at only one more spot because then it would be an even function. It's not. So we get positive negative I there as our 2 other solutions. All right? And that's what I put here. I probably should have filled that out to begin with. Because of our graph, and if we would graph this ourselves in the graph calculator and actually zoom out, you'll see it only crosses once. So we could assume from the very beginning, if we could zoom out, that the other zeros are imaginary because it only crossed the x-axis once. So that means the other zeros have to be imaginary, which they are. There's your other zeros. All right, last one here. Write f of x in factored form with the given information. It says f of -2 is 0. That means that -2 is a 0. Okay? So we put that in. You got 1, 8, 5, and -14. Drop it. Multiply and add. Multiply. Add. Multiply. Got our 0. So we have x squared plus 6x minus 7. We're looking for, oh, look at, careful. This is we're asking you to write it in factored form. It's not asking you to find the zeros. So I'm going to just factor this thing. -7 and -1 is the way to go there. So factored form then would be f of x equals, okay, now I got to be careful. Our 2 factors that we got were x plus 7 and x minus 1. They didn't give us another factor. They gave us a 0. So what is the factor that that 0 comes from? Well, if k is a 0, x minus k is a factor. So x minus -2 would be x plus 2. And there's our factored form.